Hello everyone, my name is Neetu. Today I am going to present a paper on image forgery detection using deep learning. This topic is important today because digital images are used everywhere in social media, journalism, and even in legal cases. But with modern editing tools, it's very easy to create fake or manipulated images. In this presentation, I'll explain how deep learning helps us detect these forgeries effectively and accurately. So, in today's digital world, images are a key part of communication. Unfortunately, it's a very easy to manipulate images using tools like Photoshops or some AI generators. Image forgery can be used to spread misinformation, fake news, or even tamper with evidence. So, traditional detection methods are not accurate enough because they depend on manually checking image properties. This is why deep learning is being introduced. So, deep learning, on the other hand, can automatically learn and identify hidden features that a human might miss, making it more reliable and efficient for forgery detections. So, what is image forgery? Image forgery means changing, altering, or manipulating an image to hide or fake information. There are three common types of image forgery. So, first one is a copy move forgery. That is, a part of same image is copied and pasted somewhere else. For example, cloning a background area to hide an object. Second one is image splicing, that is combining parts from two or more images to make one fake image. For instance, placing someone's face onto another person's body. Retouching. Retouching is adjusting the colors, the brightness, or removing imperfections, often used in media or advertising. These changes can be very subtle, make it hard for the human eye to notice. So, what is traditional detection method? So before deep learning, image forgery detection was depending on the handcrafted or the statistical methods. For example, error level analysis. This is one type of traditional detection method where you'll check the compression level to identify the differences in image regions. Next comes a metadata analysis. It will look at image information like date, device, and software used. However, metadata can be easily changed or removed. Everyone can change the date or the device software. The date of the software is being used or which software it is being used. We can easily manipulate those. So this can be easily detected. Then the third one is noise inconsistency. So it detects small difference in noise patterns of the images. So these are all traditional detection methods. While these methods work for simple cases, they fail when the forgery is done professionally or when the image is received multiple times. That is why deep learning methods were introduced. So they can learn much deeper and hidden clues. Why deep learning? To explain why deep learning is better and more powerful than older forgery detection techniques, we should know why traditional image was not been powerful. So in traditional image forgery detection method, it relied on manually designing features. For example, earlier system tried to detect fake images or fakes by looking at the colors, tones, or lighting or noise patterns, but these methods were limited. Every time a new type of forgery appeared, those features had to be redesigned. This made traditional systems slow, rigid, and often inaccurate. So, deep learning, especially using CNNs, changed this completely. CNNs can learn features automatically, They study thousands of real and fake images and figures out by themselves what differences usually appear in the forged areas. Unlike traditional approaches, we don't have to manually tell the model what to look for. It learns directly from the data and detects hidden patterns that even human eyes can't see. So this is the main advantage of the deep learning. That is, it will automatically learn all the features. The model doesn't, you don't have to teach what model has to do. So the model automatically identifies the features that separate real and fake images. High accuracy. So deep learning models can detect a fake over 90 to 95% accuracy. Then it handles complex forgeries, that is even advanced AI generated forgeries, that is GANs or diffusion model fakes can be detected using the deep learning method. There are two detection types. So first one is classification. Classification says whether your image is real or forged. And next one comes localization. Here it will show which part of the image is been forged. These are the two types of detections in deep learning. So next comes the system architecture or workflow of the deep learning. So first of all, you need a input image. We start with the image that need to be checked. For example, take a image and you just have to give it to the model. It will either classify whether it has been real or fake, or it might tell you where the forgery has been done in the part of that image. So this is what our model does usually. So when we input an image that needs to be checked, it might be genuine or tampered. The goal is to find whether it's real or fake, whether the manipulation has happened. So before you give it to the model, you need to do the pre-processing. So before feeding the image into the model, we have to prepare it. That is, you have to resize all the images to a fixed size and normalize the pixel values to the model that can learn consistently. Sometimes divide the image into smaller patches to detect the local changes. So this step ensures that all images are in the same format and the quality for fair comparisons. Then after doing a standardization, or you can say that if you after bringing the image to a same format and the quality, you will give that image to the deep learning model. So when it enters this deep learning model, it might be the models might be acting differently. Like the model which you take will be different, and model which I take might be the different one. So there are different models. Some are CNN. CNNs are the famous models. So the CNN captures these local details, that is small difference in the texture, color, or lightning that reveal manipulation. Then comes a transformers. Transformers will look at the image globally. It can detect inconsistency between the distant regions. Together, they generate internal features that represent what's normal and what's suspicious in the image. After you know that if it is not normal, whether it is normal or it is suspicious, now next comes the next level is you are going to either classify it, or you have to detect which part of the image has been faked. So based on the model, whatever the model you have taken, you will get an output. So in a classification mode, it will simply give you the output whether your image is a real or forged. In localization mode, it creates a heat map that highlights the tampered regions. For example, red areas might show fake parts, or green areas, or something like which will tell you which area is been faked. So this visual output helps investigators or forensic experts pinpoint the forgeries. Finally, the system gives a clear result, whether the image is genuine or forged, and if possible, marks the forged areas. This can be very helpful in journalism, legal cases, and social media verifications. So next comes model designs. So deep learning models are used for forgery detections, so that can be of different types. So as I said, the CNN based models, for example, ResNet, VGG, and EfficientNet are all these are CNN based models. These models classify whether an image is fake or not. Encoder and decoder models are also there, which is, for example, UNet and SegNet are of these types. These are used for localization, that is, highlighting the forged pixels. Next comes vision transformers, that is VITs. Transformers capture long range dependencies in an image, useful for subtle or global manipulations. Next comes hybrid models. Hybrid models will combine both CNNs and transformers to get both local and global features. Choosing the right architecture depends on the type of forgery we want to detect. So there are data sets used for deep learning. To train these deep learning models, we need large data sets of real and forged images. So some of the popular ones used are Cassia data sets, which contains various spliced and copy move forgeries. Uh, Columbia dataset, which are of high quality splicing datasets. Coverage datasets are of focuses on copy move manipulations. NIST NIMBLE 2017 are the standard forensic dataset used in evaluation. These datasets helps model learn different types of manipulation patterns from diverse examples. Model is trained, we measure its performance using several metrics. That is, either it can be accuracy, precision, recall, F1 score, and intersection over union. So accuracy is how often the model is correct. Precision is how many detected fakes are truly fake, and recall is how many of the actual fakes were found. F1 score is a balance between the precision and recall. IOU, that is intersection over union, used in localization to check how closely the detected area matches the true tampered area. These metrics help us understand how reliable and robust our model is. Next comes the challenges in deep learning. Even though deep learning is powerful, it still faces some challenges. That is either in the form of generalization, high quality forensic, forgeries, or limited label data or adversarial attacks. So generalization, models trained on one data set may not perform well on another. And high quality forgeries, AI generated fakes like those made by GANs are becoming extremely realistic. So limited labeled data, that is creating large annotated data set, is time consuming. Adversarial attacks, that is hackers can slightly modify images to fool the detection system. So overcoming these challenges is a key area of ongoing research. So the future enhancement is, you can go for a hybrid architectures, that is combining CNNs and transformers. Then self-supervised learning, that is learning models without labeled data. Then comes multi-model detection, that is using image content plus metadata or sensor noise. And then comes a blockchain verification, that is tracking the origin and authenticity of images. These approaches aim to make forgery detection faster and more reliable and adaptable to new manipulation methods. So, so the conclusion is deep learning has revolutionized image forgery detections. It learns patterns automatically and works well for both simple and complex manipulations. CNNs and transformers significantly outperform older techniques. However, a forgery creation technology improves. We also need continuous innovations in detection methods to maintain digital trust and authenticity. These are the references. Thank you.